at the end of the quarter or end of the year at that point. For this one, it says Dina ran 4 4/5 miles on Monday, 3 1/3 miles on Tuesday. So her total distance is between which of these two numbers? So what's the first thing we got to do? If the total distance, if it's talking about the total distance, what do we need to find?
You need to add them up, right?
We need to add them up,
Yeah.
right? So I'm going to take 2 4/5 plus 3 1/3. Y'all remember how to add mixed numbers? You guys, remember how to add mixed numbers? Alright, we can add the bigger numbers first, so I'm going to rewrite it first. So 2 and 3. But then, what do we have to do with the little fraction? Common denominator. What's our common denominator between 5 and 3? 15. Remember, it's just the smallest number that both of you can multiply into. Now, if I multiply 5 by what to get 15, I'm going to do the same thing for 4. So 5 times what gives me 15? 3. 4 times 3 is 12. 3 times what gives me 15? 5. So 1 times 5 is 5. So now I can add them together. Add the bigger numbers. So this is going to be 5. Then add the fractions. So 12 plus 5 is 17 over 15. Now, do you remember what we do with this number, with the fraction now? We can. Remember, if the numerator is bigger than the denominator, we can add 1 to the big number. So now, this will become a 6. But remember, it's 15 over 15 equals 1, right? So if 15 over 15 equals 1, which I added to my 5, how many 15s are left? If I have 17, if I take 15 away to give me my 1, which is 6, how many are left? 2. Yeah, sorry. So how many 15ths are left? How did I get what?
6.
Because, remember, I have 17 15ths here. 15 15ths equals 1, right? So I take 15 out of the 17, and I add my 1 to the 5. Then the 2 is how many's left. It stays there. Now we've got, this is the total number of miles she's run. Is it in between 5 1/2 and 5 2/3? Yes or no? Is 6 2/15 between 5 1/2 and 5 2/3? No. What about 5 2/3 and 6? No. What about 6 6 1/3? Well, maybe. We know it's bigger than 6, right? So it's a possibility. But what's the issue here? Can we compare these two fractions, the 1/3 and the 2/15? No. But if we change this to what we can compare, what denominator does that need to be? 15. Well, it's nice. We did 1/3 somewhere up here. Yeah. We already changed 1/3 to 15 to 5 over 15. So this is 6 and 5 over 15. So now, is this between 6 and 6 1/3?
Yeah.
Yes, so that's our answer. So that one was a lot of working with fractions. A lot of working with fractions. All right, y'all have any questions on the homework from last night?
Number 14.
Number 14? All right, so let's look at number 14. All right, so 14. Square root of k plus 7 equals 3 root 2. Now, this 13 and 14 were a little different than what we did in class. The square roots are already technically by themselves, so I'm going to go ahead and square both sides. So on the left side, what do I get?
K plus 7.
K plus 7. On the right side, now when I have two things that I'm squaring,
6.
I'm going to square the 3 and the square root of 2. So if I square root of 3, what do I get?
6.
And be careful. 9.
Yeah, 9.
So 9 times what? 2. Remember, the square root and the square cancel each other out there. So we're going to have K plus 7 equals 9 times 2. So K plus 7 equals what? 18. Then what do I do? So K equals 11. Questions? Alright, I'll check homework at the end. We should have time to do it. Now, I put in grades last night, so if you're missing any on the same worksheet from yesterday, and the issue today is that we have a variable on the outside most of the time. So we've got this variable inside the radical just like yesterday. Now we've got variables on the outside as well. The issue is, if we have a variable on the outside of the radical, we have a chance for what's called an extraneous solution. Was everybody here yesterday? So everybody has this worksheet that they should be getting out? They should be getting out. Alright, so all this extraneous solution, this is a fancy math word. Big fancy math word for saying one or more of the solutions may not work. That's what this means. One or more of the solutions may not work. So today, as soon as we get our answers, we get x equals 7, x equals -1, we got to check them. We got to plug them back in to our original problem for the x and see if they work. That's essentially the only thing that's different today when we solve these. We got to take our answers, plug them back into the original equation, and check and see if they work. Now, we're also going to talk a little bit about factoring today, so we're going to have to do that some. So when we get there, we'll have to remember. We'll have to work on it. So, is my square root by itself here? No. What do I do to get it by itself? Nope, don't square it yet.
Plus 3.
No, remember. Alright, the confusion yesterday. Anything that's under the square root, I can't move. I want to move the 5 over, yep. So I subtract 5. I'll get x minus, the square root of x minus 3 equals x minus 5. Now we can do what? Square. So I square both sides. But here's a little, it's going to be more work today, unfortunately. Because what we're doing here is, how do I rewrite this x minus 5 squared? What's another way to write it? No. Alright, so look. Don't write this down. If I have x squared, that's the same thing as x times itself, right? So what I want to do is I want to take this and take x minus 5 and multiply it by itself, right? So I'm going to take that and multiply it by what?
X minus 5.
X minus 5.
What's that word called?
What word?
The opposite. Not in the
It's not the opposite, but it's kind of like the conjugate. It's similar to the conjugate, but you're not changing the sign in the middle. You're just multiplying it by itself. So now, what's that word that we're going to use to multiply this out? Four letters? FOIL. So I'm foiling this out at this point. So to do that, I'm going to do my first two. My x times x to give me x squared. Outside, so x times -5 will be minus 5x. The insides, -5 and x, so minus 5x. -5 times -5 is positive 25. Kind of remember that a little bit? Well, now I'm going to take my x minus 3, which is the same thing. I just take whatever's underneath the square root. I'm setting it equal. I'm bringing this whole piece down here. So I'll have x squared minus. Now what can I do here?
Well, they add because they're the same sign,
So
10x.
minus 10x plus 25. So I bring this back down there. Now, here's where the factoring starts. Whenever I factor something, I have to set the whole equation equal to what? What? 0. I've got to get everything on one side of my equal sign and 0 on the other. Now, the key is, I want to keep my x squared term positive. So I'm going to move all this stuff to the left, or I'm going to move this stuff over to the right. If I want this positive,
You can move to the right.
I'm moving this stuff over there, because this doesn't change sign if I don't move it. So I'm going to subtract x from both sides. I'm going to add 3 to both sides. So I'm going to have 0 equals x squared minus 11x plus 28. And this is where we're going to factor. So now, there are two ways that you're going to factor during this section. The first one is like this, where we have 3 terms. Remember, a term is just each individual piece that we're adding or subtracting together. If we have 3 terms, 3 pieces, I want to think of 2 numbers that multiply to the last number and add to the middle number. Multiply to the last number, add to the middle number. 7 and 4. 7 times 4 gives me 28. Now, what do I have to do with the signs of 7 and 4 so they add to negative 11? Alright, you're on the right track. They both have to be negative. Because remember,
2 negatives equal positive.
that's the big thing. 2 negatives equal a positive on the backside. So the way we're going to write that is going to be 0 equals x minus 7, x minus 4. The order there doesn't matter. You could have put x minus 4, x minus 7. It does not matter. It'll work the same way. We'll get the same answers. It doesn't matter if the way is flipped. Now, I'm going to set each one equal to 0 and solve for x. So I have 0 equals x minus 7, and 0 equals x minus 4. So on the left side, what is my x going to equal?
X equals positive 7.
X equals positive 7. I add 7 to both sides. What about on the right side? What does x equal? Positive 4. Again, I add 4 to both sides. X equals 4. Now, this is the part where we've got to keep going, whereas yesterday we could have stopped. But today, because we have this x on the outside up here, we've got to make sure that both of these answers work. So I'm plugging in 7. I'm doing it one at a time. I'm going to plug in 7 for both x's up at the top. I'm going to see what happens. Then I'm going to plug the 4 into the x's at the top. So if I plug in 7 for x here and x here, I want both sides to equal 7. Since 7 is the only thing over here, I want this left side to equal 7. So if I do 7 minus 3, I get what? 4. So what's the square root of 4? 2. What's 2 plus 5? 7. So 7 equals 7. This one's going to work. So I'm going to check that one off. Now we got to check 4. I'm going to plug 4 in for both. So since x is the only thing over here, I want this side to equal 4. So what's 4 minus 3? 1. What's the square root of 1? 1. So 1 plus 5 is?
6.
Does 6 equal 4?
No.
No, so that one doesn't work. So my only answer is x equals 7. I think we do one of them. Yeah, the next one actually both answers work. But you will always end up with one, at least one of them work. You will end up with at least one of them work.
Would you mind, like, if we worked it out and we try to see if they equal each other? Would you mind if we worked it out?
Oh yeah, you can work it out, absolutely.
Okay.
Yeah, absolutely. Alright, let's move on to 7. What's the first thing we got to do here?
Add x.
Add x, good. So I'm going to get square root of x plus 1 equals x plus 1. What do I do now? Square both of them. So I'm going to come over off the side again. I'm going to have x plus 1 times x plus 1. So I'm going to have x times x gives me x squared. X times 1 to give me just plus x. 1 times x to give me plus x again, and then 1 times 1 is a plus 1. Everybody good with that? So that's, I'm plugging that in, I'm bringing that back down. So x plus 1 equals x squared. I can add these again.
So x to the 4 plus 1?
Plus 2x plus 1. Remember, alright, we can't combine these two because there's an exponent here, not an exponent here. When we're adding two variables, we don't add an exponent, we add the number out front. Alright? If we're multiplying an x and an x, then we would add the exponent. We alright? Jared, you good? Now what am I going to do here? Am I moving everything to the right side or everything to the left side? To the right. So I'm going to subtract x and subtract 1. So I'm going to have 0 equals x squared minus x. And then the 1's go away. Now, this is a different, it's still factoring, but different type of factoring. We only have 2 terms here. So when we only have 2 terms, we're looking for something that's common in both pieces. So what's common in both pieces? They both have an x. Technically, how many x's are here? It's x times x, right? So I have 2. So when I factor out an x, I'm going to be left with 1 there. So I'm going to have 0 equals x on the outside. So when I factor something out, I bring it to the front and put the rest in parentheses. So I'm going to have x minus 1. Now, that minus 1, I'm going to leave this sign the same. I've got to put this 1 here as a placeholder. Because to check ourselves, we can multiply this back out. We can distribute the x and it should equal this. So if I do x times x, I get x squared. X times negative 1 is minus x. But if I didn't have that there, then this second term wouldn't be there, would it? So whenever we factor something out in our minds, it goes away. We really have to put either a plus or minus 1 there. So that if we were to check ourselves and go back the other direction, that term is still there.
Wouldn't matter what you did negative or positive.
Yes, because it has to match this sign. If this was positive, I put a positive here. And then it's just like the last one. We've set it equal to 0. We factored. So I'm going to say x equals 0 and x minus 1 equals 0. Well, the x equals 0 on the left is done. It's solved for. On the right, what are we going to get? X equals 1 because I'm adding 1 to both sides. Are we done? No, we got to plug them back in, check our work. So if I plug 0 in for x and x, well, what's 0 plus 1? 1. What's the square root of 1? What's 1 minus 0? 1. So 1 equals 1, that checks.
Well, there's always a 1 in front of the x.
Alright, so what do you mean?
Like, I thought it was
Like
just
here?
Yeah, it was just a regular x, it's 1. So.
Alright, but now we're plugging this in for it.
Oh, yeah.
Alright? So now I've got 1 here. Now I've got 1 plus 1 is what?
2.
Hold up, what did I do?
1 plus 1 is 2, that means both of them are.
No, oh, it's right here. What did I do here? Going from this step right here. What should that be? X squared.
Should be just x.
It should be positive x, right? Because I did 2 minus 1 is positive 1. There we go. Alright, so all we got to do is change some signs and we're fine. Sorry about that. So I'm going to have plus x plus 1 plus 1, and then these will be minus. Sorry. So that'll be negative 1. So minus, minus, and negative 1. Alright, so now we're good. Now we're good. This should work. So I changed all those. Negative 1. Plug in negative 1. So negative 1 plus 1 is what? 0. The square root of 0 is 0. Now, I'm going to rewrite it up here. So I'm going to have 0 minus, and I'm plugging in negative 1. So what am I doing here? I have 0 minus a negative. What does minus and negative mean? Positive. So 0 plus 1 is 1. So 1 equals 1. So that checks too. So both of these check. So both of these are actually answers. So my true answer would be x equals 0 and negative 1. Questions so far? Alright, let's do 8. Now 8 isn't meant to trick y'all. But what's going on here? They're both under a radical. Are there any variables outside the radical? No. So we're going to have to check our answers at the end. We're not. It's just like yesterday. So I'm going to go ahead and square both sides. So then I'm left with what's underneath. I've got 2x plus 1 is 5 minus 2x. Now again, it doesn't matter which way you solve this. I'm going to move.
Is it 4?
You're close.
Oh.
So I'm going to add 2x to both sides. The only reason I moved that 2x over to the left instead of moving the other one to the right is because I don't like negative numbers as much as I like positive numbers. So I'm going to keep my x's to be positive, so 4x plus 1 equals 5. Then I'll subtract 1. So I get 4x equals 5. What's the last step? And not 5.
It should be 4.
Should equal 4.
Divide by 4.
Divide by 4. So x equals 1. Questions? Y'all try 9. Do my foiling. I've got to do t plus 3 times t plus 3. Remember, it's the exact same. Whatever's inside the parentheses times itself. So that'll be t squared plus 3t plus 3t plus 9. So I'm going to bring that down. I'll get t squared plus 6t plus 9. Then what?
Subtract 5.
I'm going to subtract both of them from, I'm going to do minus t and minus 5. So minus t, minus 5. So good. I'm going to get 0 equals 0 equals t squared plus 5t plus 4. So now I've got 3 terms. How am I going to factor this? I have 3 terms. How can I factor this?
You got 5 and 4.
Multiplies 4, adds 5. 4 and 1. So I'll have 0 equals t plus 4, t plus 1. Again, that order does not matter in the way that you write t plus 4 or t minus 1. So then t plus 4 equals 0, t plus 1 equals 0. So what does t equal on the left? T equals -4. On the right, t equals -1. What do we have to do now? Plug it back in. Now when we plug this back in, we're plugging it back into the original. We're not worried about the squares that we wrote up there. We're just worried about the original. So if I plug in -4, what is -4 plus 5? 1. What's the square root of 1? 1. So I have 1 over here. What's -4 plus 3? -1. So does 1 equal -1? No. Absolute value, yes, but not the way we want it to. Now I'm going to plug in -1. So -1 plus 5 is what? 4. What's the square root of 4? 2. What is -1 plus 3? 2. 2 equals 2. That's an answer. What are you about to ask? No. What I'm saying is, We go back to the original before we do any work to it.
Yeah, I realize.
We go back to the original before doing any work. Alright, the homework for today is page 644, 15 to 20. So the other 6 problems in that section.